Hello everyone. Today we will solve question number 21 to question number 40. So the first question is given as doping NiO with the lithium 2O in presence of air increases the electric conductivity due to. So basically in this case Ni2 plus is replaced by lithium plus. Then there will be one hole will appear because this is plus 1 charge and this is plus 2 charge. So that will create a charge imbalance. Okay. So to maintain the neutrality, some Ni will oxidize to Ni3 plus. And ये जो Ni3 plus साइड से ये एक्ट करता है पॉजिटिव होल जैसे. So this is making it a p type of semiconductor. So the correct answer will be C, the formation of excess holes in the NiO lattice. In the question number 22, which one of the following statement regarding the ligand field theory is correct? So ligand field theory is called LFT, which said that modified CFT. In CFT everything is right but interaction is electrostatic. But LFT said that there is some sense of bonding between the metal and ligand, that is must be a covalent bonding. So not only a electrostatic interaction. So this LFT accounts the covalency in the metal ligand orbital overlap. Now the first statement is given as it is considered which atomic orbital metal are used for the bonding and predicted the shape of stability of the complex. However, it fails to explain the electronic spectra. That is not true. We can explain this. It considered that bonding in the coordination complex is purely electrostatic, not here covalency के बारे में भी डिस्कस किया है. It provides some allowance for the possibility of some covalent interaction between the metal orbital and sigma overlap. Okay, fine. Pi overlap also possible, and C option is correct. In the question number 23, the hybridization of boron oxygen atom in the boric acid. Boric acid, boron, this is actually trigonal planar kind of arrangement. OH. So this is sp2 hybridized and oxygen is sp3 hybridized. So correct answer will be D. The question number 24, how many resonating structure of CO3 minus? So basically we know there are 3 resonating structure. If we mark it 1, 2, 3, then if we mark oxygen by 1, 2, 3, then another will be this O minus carbon, this O minus, another will be this carbon, double bond O minus, O minus. Total 3 resonating structures are possible. In the question number 25, which one of the following statement is not correct with respect to the geometry and the magnetism of the given complex? NiCN whole 2 square planar and diamagnetic, that is true. And NiCl, which not correct. NiCl is a tetrahedral and paramagnetic, that is also true. FeCN is an octahedral diamagnetic, that is true. But NiCO tetrahedral and paramagnetic, no, that is not true. Because NiCO whole 4, here this is D8S2. Okay. So this is pair up into D10 system. So this is a diamagnetic component. It must be a tetrahedral. So correct answer will be D. In the question number 26, consider the following 3-step reaction. NiH2O. Actually the ethylene is ethylene diamine. En is substituting H2O molecule. So इधर हमको okay, let's see the options available. The number of molecule on the product side will be greater than the number of molecule on the substrate side, indicating increasing in the entropy of chelation by chelation with more chelation. That is true statement. So option A is correct. In the question number 27, the IUPAC name of this compound. So basically, first tetrapyridine, platinum. Okay, it's fine. Now we have to balance the oxygen state basically. So if the oxygen state here is +1, then its charge should be -1, and this is +3, like this. Considering the first option, that is feasible, but second option, if we take this is +3 state, then it will be -3, so this will be +1. So this option not correct. In the C option, tetrachloroplatinum, not first pyridine ligand, tetrapyridine platinum 2 and tetrachloroplatinum 2. So between A and D, actually platinum exists in the +2 or +4 state. So existing in +1 and +3 is not that much stable. So option D is correct. If it is +2, whole compound is -2, then it will also +2. Let's see the question number 28. So which one of the following statement is correct about the structure given above? So इधर कुछ 4 स्ट्रक्चर दिया हुआ है, तो हमें एक्सप्लेन करना है कि इनका नाम क्या है. So the first option 1 towards cis and trans tetramine dichloro cobalt 3. Okay, 1 2 tetramine. Okay, dichloro cobalt. Given question, all the metals are +3 state, but in the first scenario, only anionic ligand chlorine 2 anionic ligand means cobalt will be +2 charge, but here no option has that +2 charge, so there is something misprinting, I think, in the question. So in general, if we solve the question, this one is a FAC isomer, and this chlorine, this is a MAR isomer. So 3 and 4 form the FAC and MAR isomer. In the second option, 3 and 4 form FAC-MAR isomer. So another FAC-MAR isomer. So option B is correct. In the question number 29, which one of the following statement true for the geometrical and the optical isomer present for the monodentate ligand Ma2B2C2? In this case scenario, suppose this is central metal, and if we draw, this is a square plane, this is the axial, like this metal, like this. No, so if we arrange it, this is A, B, and CC. Here CC trans, and similarly if we say SC, then BB trans, here BB trans. Similarly this is BC, this is BC, A trans. Okay, if we say all trans, A, B, B, C, C, this is all trans. And another isomer geometrical kind possible. Suppose this is SC, and after that, if we exchange it, this is AB and this is BC. This is actually all cis, and this is optically active. Okay, so total 5 geometrical isomers are possible, and 1 is optically active. Option B is correct. In the question number 30, which one of the following will not make an acidic buffer solution? In this problem, so first of all, A is given as 100 ml, volume 0.1 normal of acetic acid. So the equivalence is 100 into 0.1, this is 10 milli equivalence, plus 25 into 0.4, this is also milli equivalence. So both have the same strength. So to prepare a acidic buffer solution, the weak acid plus salt must present. But in this scenario, if both are neutralized, so the acidic buffer is not possible. So option is A. If we see other option like this and this, in this case scenario, the milli equivalent of acetic acid is same, 10 milli equivalent plus 3 into 25. This is 7.5 milli equivalence. So this is acid, weak acid, this is a base. So 7.5 plus 7.5 gives 7.5. This is salt. Okay. So remaining 2.5 will be weak acid plus 7.5 will be salt. So it will form the buffer solution. So option A is correct. In the question number 31, in the trialkyl amine, the p character of the lone pair of electron of nitrogen atom that is increases with the bulk of the alkyl group. Let's understand the basic concept. Suppose this is R1, this is R2, this is R3. In general, if the bulkiness of this group are increasing, then the theta, the bond angle, is also increases. We know that theta is directly proportional to the S character. So more the angle, more will be S character. So more the S character is used between this bonding, so more will be P character in the lone pair. But if I say about the donation, if it is donating, is acts as a Lewis base and donating to other metal or anything, so due to this bulkiness, the donation is weak. Okay, so this is the basic concept about this bulkier amyl ligand. In the first option, it is given as the increasing with the bulkier, the P character is increases with the bulkier alkyl group, that is true, resulting in a superior donation of the lone pair towards the acid. But the superior donation is not possible. It is wrong statement. This bulkiness will interrupt the binding to the metal. Decreases with the bulkier, that is not true. Increases with the bulkier, that is true, resulting in a poor donation lone pair towards, that is the correct answer, option C. In the question number 32, which one of the following statement regarding the Oswald law of dilution is not correct? It is only applicable to the weak electrolyte at the equilibrium where the dissociation constant K can be related to the degree of ionization alpha and constant. This is a true statement, but here it is asking the not correct statement. A is completely right statement. It is only valid for the dilute solutions where the concentration of the electrolyte is very low. That is also a true statement. It is applicable to a strong as well as weak electrolytes and extreme dilution. This is not a correct statement, but according to the question, the option C is correct. The question number 33. What happens to the ionic product Kw of water at 25 degrees when added 1 ml of the 0.1 normal HCl followed by the 1 ml 0.1 normal of NaOH? Know that Kw is the ionic product is concentration of H plus and concentration of OH minus. The strength of both are same. If we mix them, this HCl plus NaOH will generate the NaCl plus H2O, and also it will not affect the Kw value because it is a temperature dependent quantity. Okay, so that's why this is remain constant. The option A is correct. In the question number 34, which one of the following concentration of H plus ion indicates an acidic pH of water at 100 degrees centigrade? Kw is given. As we know that Kw is equals to concentration of acid H plus into concentration of OH minus. But for neutral system, the concentration of H plus is whole square. So concentration of H plus is equals to root over of Kw. That is root over of 5.5 into 10 to the power minus 13. And this value approximately is 7.41 into 10 to the power minus 7 molar. So this is for the neutral one. But if we want to say कि एक solution acidic है तो concentration of proton must be greater than the H plus of the solution must be greater than 7.41 into 10 to the power minus 7 molar. तो एक ही option correct है. This is option C. In the question 35, what will be the pH of a solution produced by adding 20 ml 1 molar HCl to the 1 liter sodium solution containing 0.1 molar of acetic acid and 0.1 molar of sodium acetate, like this? Okay, fine. So this is a question deals with the buffered solution. First of all, given that there is a buffered solution, if we add HCl, so how much the pH change takes place? First of all, let's find the number of moles of acetic acid. This is equals to 1 liter solution into 0.1 molar. This is 0.1 moles. Okay, and number of NaOSC, sodium acetate number of moles, this is 1 liter into 0.1. Similarly, this is 0.1 mole. For HCl, this is 0.02 liter 20 ml into 1. This is 0.02 mole. Now this kind of reaction will take place. So HCl is a strong electrolyte. It will dissociate to give in the solution H plus and Cl minus. And on the other hand, if we say that the salt sodium acetate CH3CO minus Na, not this is a sodium acetate, so it will dissociate to give CH3CO minus plus Na plus. This H plus will adsorb to this and it will give CH3COH. So what is happening? It is decreasing the concentration of CH3CONA and increasing concentration of this acetic acid. So new acid concentration, new salt concentration will change. Now new salt concentration is 0.1 minus 0.02. This is equals to 0.08. A new acid concentration is plus 0.02. This is equals to 0.12 mole basically. So let's clean this up. If we use the Henderson equation, the pH is equals to pKa plus log of concentration of salt by acid. So this value will be K is equals to 1.75 into 10 to the power minus 5. Now minus log of K is equals to minus log 1.75 into 10 to the power minus 5. So if we break it down, so it will be 5 minus 1.75 this value is 5 minus 0.24. Now the pKa value is, this value is 4.76. now this is 4.76 plus log of salt is 0.08, 0.12. so the final value is 4.584. so option A is correct. The question number 36. A basic buffer solution is formed by mixing the aqueous solution. Basic buffer means that weak base plus its salt. Okay, a weak base and its salt. Option A is correct. The question number 37. In a quantitative volumetric analysis for the iodometric determination of copper, what will be the required amount of the copper 5H2 preparing 100 ml in by 40 standard solution? Reaction involve this. Molecular weight is given as this. So basically this is a iodometric kind of reaction. If I see that if 1 mole of Cu2 plus will react with the iodine and it will release 1 mole, half mole of iodine. Okay, and that iodine will react with the, that half mole iodine will react with the 1 mole of H2O3 2 minus. So the equivalence weight of the CuSO4 is equals to the its molecular weight, because N factor is equals to 1, so that the equivalence weight is equals to 159.60 gram. We can explain it in another way, that Cu2 plus is gaining 1 electron and converting to the Cu plus. So 1 mole is gaining 1 electron. If we say that 1 mole CuSO4, it has Cu2 plus of 1 mole, so N factor is 1 for this also. Now the normality is equals to 1 by 40. This is 0.025 normality, and volume is 0.1 liter. Now we have to find the how much mass is produced. So we know that normality is number of equivalents divided by volume. So number of equivalents is equals to weight by the equivalent weight divided by volume. So that weight is equals to normality into volume into equivalence weight. So normality value 0.025 and volume has 0.1 liter and equivalence weight is 159.60. Now this value is 0.39 gram. So correct answer will be C. The question number 38. Consider the following characteristics for the primary standard substances. The substances has a high formula weight. The substances is 100% pure with a very less impurity of only 0.01 to 0.02%. The substance is stable independently at a room temperature. The substance involved in the reaction which equilibrium for right obtained. Okay, fine. So above statement are correct for which one of the following pair of substances? So this is actually true for primary standard substances. You have to find which are the primary standard. So NaOH, this is not a primary standard. KMnO4, this is not a primary standard, this is secondary. Oxalic acid and K2Cr2O7, this is a primary standard both. So option is C is correct. In the question number 39, in order to determine amount of calcium 2 plus through the complex symmetric titration with the EDTA using the Ericlum black tea, which one of the following may be adapted obtain the sharp end point? Let's see. So इधर जो mechanism होता है पहले वो डिस्कस करते हैं. So the titration, in this titration, we take Ca2 plus as analyte plus EBT as erythrom black tea as indicator. So first of all, Ca-EBT complex is formed. Okay, it is general case, but it is a weak complex. So the color is not strong enough. So if we add EDTA, then the scenario is that it will substitute the EBT and Ca-EDTA will form. But at the end point, what will happen when all the Ca2 plus is finished, and if we add EDTA one drop more, but the color change not sharp, color change is not sharp. So the thing is that due to this the color change is not sharp. So what we will do, let's see. To avoid this, here Ca2 plus and we add some Mg2 plus, and this Mg plus EBT will form a stable complex Mg-EBT, and the color of this is wine red. So this is a good visible color. And on the other hand, this calcium is free for binding with EDTA, so it will bind together. Ca-EDTA will form. So at end point when this calcium is finished, then Mg-EBT complex will react with the EDTA and it will form Mg-EDTA complex plus EBT indicator, and the color is blue. This is blue color, so it will show a sharp endpoint. So adding a little amount of magnesium should enhance the visibility of sharp endpoint. So option B is correct. In the question number 40, consider an acid-base indicator HLN as a weak acid which exhibit red color in the non-ionized form and the blue color in the ionized form. Okay, red blue. What is the general transition range in terms of pH unit between the colors of an indicator according to this equation, provided that your eyes discern one color only when it is 10 times as intense as the other? So in this case, our eyes can signify the color if it is 10 times strong. Means two scenario arises. Case 1. So case 1, the concentration of H lon concentration is 10 times of indicator minus, means this red concentration is 10 times of blue. Okay, like this. So if we put in the equation, pH is equals to pK is fixed, pK plus log of concentration of indicator minus H indicator. Now this value will be pK plus log of. So if we do concentration of indicator divided by, from this, divided by concentration of H indicator, this is 1 by 10. So this is also 1 by 10. pK minus 1 pH. In the case 2, when this 10 times of H indicator is equals to concentration of indicator, then the pH is equals to pK log 10. So pK plus 1. So the transition range will be this pK plus 1 minus pk plus 1, that is equals to 2. Option B is correct. Thanks for watching the video.